Hello everyone, welcome to the Silicon Room. In this video I will explain how you can control the speed of the motor using a potentiometer with STM32 nuclear board. Let's get started. Firstly, I am opening a new STM32 project by selecting the STM32 nuclear board. Then I start configuring the ADC settings because I will be using a potentiometer in the project. I choose the pin for connecting the potentiometer to the microcontroller from the mode section. I prefer to use in0, which corresponds to the A port's 0th port line. You can select any pin you like. The ADC resolution comes default as 12 bits. If you want, you can change this value, but I prefer to use ADC at maximum resolution. With a resolution of 12 bits, the values we read will range from 0 to 4095. Remember that if you change the resolution, the values you read will also change, so keep this in mind during the software development step. For example, if you set the resolution to 10 bits, the values you read will range from 0 to 1023. Pay attention to these details. So, in this part, we simply switch from continuous conversion mode disabled to enable, and our ADC settings are completed. Now, we can move on to timer section. I am choosing the timer 3 to generate a PWM signal. Then, I check in the datasheet which register is responsible for timer 3. I need to check the APB1 register for timer 3. The timer clock of the APB1 register is 84 MHz. I will adjust the frequency settings based on this information. I return to the timer section and change the clock source to internal clock. And I choose the channel 4 for the PWM signal. It doesn't matter which channel you choose. You can select whichever you prefer. Now it's time to adjust the frequency. The frequency adjustment is very simple. To obtain the desired frequency value, you simply multiply the values you write to the autoload register and press scalar. Then divide the result by the APB1 clock source value. For example, if I want to generate a 1 kHz signal, I write the 84 to the press scalar and 1000 to the autoload register. I will achieve a 1 kHz signal. Remember that both registers are 16-bit when assigned to values them. Counter period, also known as the autoload register, determines the resolution of the signal. For example, if I want a PWM signal with a %40 duty cycle, I need to send the value of 400 to the timer. You can adjust the frequency or resolution of your signal as you like, based on the instruction I provided. I will use these values in the video. We have completed all settings related to PWM and ADC. Finally, I am defining two output pins to control the motor. I choose these two pins because they are easy to connect, but you can choose whichever you prefer. Now we can move on to the software stage. I am finding the necessary code snippets to use the ADC. After finding the necessary code snippets, I am making all the settings inside a function named ADC read. I am storing the value read from the potentiometer into a variable named ADC value. I am dividing the value read from the potentiometer by 4 and storing it in the variable named speed. The reason I'm performing this operation is because the ADC is 12 bits and the auto reload register is set to a value of 1000. So, by dividing the values from the potentiometer by 4, I adapt them according to the auto reload register value of 1000. This way, the motor speed varies based on the potentiometer. After these operations, I move on to configuring the timer. First, I start the timer. I write a new function called speed control. I activate one pin and deactivate the other to make the motor rotate. Finally, I write the value read from the potentiometer into the timer to complete the software stage. Now we can proceed to testing phase.